Hello everyone, in this video I shall talk about the unbounded solution in linear programming problem. For this I've taken an example, maximize z is equal to 5x1, 6x2, x3 and subject to these constraints. And I've also converted the inequalities into equalities by adding s1, s2 and s3 as the slack variables. So now what I'll do is I'll I've made the table basic variable quantity x1, x2, x3 and I'll fill the values in this table, and then we'll discuss the concept of unbounded solution. So simply the basic variable in this case are s1, s2 and s3, and the quantity column is 5, 2. So these come in the quantity column, so this is 5, 2 and 3, and this is the constraints 9, the constraints, objective constraints. So the first value is here 9, 3, minus 2, 1, 1, 1. This is always an identity matrix. So this is 0, 0, 0, 0. So this is 4, 2 and minus 1 over here from this equation. So I've posted them here, and this is 1, 1 minus 4 and 1. So this is what we do. So I simply find out the Cj column. Cj is here 5, 6, 1 and 0, 0, 0, and Cj minus Zj. So Zj would be my contribution. So this is 0 in this case. So 0, 0, 0, and multiplying these, 0 into 5 plus 0 into 2 plus 0 into 3. So this matrix is entirely Zj is 0. So then I go to Cj minus Zj, which is my contribution. So this is 5 minus 5, 6, 1, 0, 0, 0, and I enter the variable which is the highest in maximization case. So this is my key column. This is my key column. And how do I find my key row? The minimum ratio column. So how do I find? This is quantity divided by the elements of the key column. So here it is 5 divided by 3, 2 divided by 2 and 3 divided by minus 4. So this is 5 by 3, 1, and this is a negative value. So in this case I have to choose the minimum value, which is the positive value. So this is 2 point something or 1 point something, but this is lesser than this. So this becomes my key row. So continuing with this table, now I go to Simplex table 2. So from this Simplex table 2, simply I'll make a table quickly and I'll jot down the values. Basic variable quantity x1, x2, x3, s1, s2 and s3, and simply now what I'll do is the key variable. So the key column, the entering column is x2 and the exiting column is s2. So s2 would move out and x1 will come in. So s1 remains at its place, x2 enters, s2 is removed, s3, and now the values that I'll calculate. So you can watch my previous videos for finding out how to calculate the values for the key and the non-key rows. I've discussed a complete problem on Simplex. So assuming that you know them, I'll simply discuss the problem of unbounded. So first the key row. So it is dividing all the elements. So the key row is the key column is this and the key row is this. So the key element is 2. So dividing all the elements by the key element, I get the components of the key row. So it is 1, 2, 1 minus 1 by 2, 0, 1 by 2 and 0, and the minimum ratio column. So the non-key rows are S1 and S3. So how to compute the values for S1? Simply jot down the previous non-key row and then minus, 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 and the now a new key row is jotted down, and then it is multiplied with the elements corresponding to the row, that is corresponding to the key element, that is 3 in this case. So it is 3 in this case, this is 3 in this case. So simply by calculating the values in this way, I get the values of the non-key row, which is S1 in this case. So the values come to be 2, 3, 0, minus 1 by 2, 1 minus 3 by 2, and 0, and for S3 similarly calculating the values. Now the problem comes here is here the values are 5, 6 as usual, 1, 0, 0, 0. So I reach at ZJ, and this is 0 for x1, x2. This is the now the contribution 6 and 0. So here I get this value 6, 12, 6 minus 3 and 0, 3. So this is the values I get, 3 and 0. So now Cj minus Zj again. So 5 minus 7. So this is minus 7. 6 minus 6. This is 0. This is 4. This is 0. This is minus 3. And this is 0. Now entering. This is the highest. So this will be the key column. While finding the minimum ratio column. Now what happens is 2 divided by this, 1 divided by this, 7 divided by this. Since all these values are negative, so my entire minimum ratio column becomes negative, and this case is called the case of unbounded solution. When my minimum ratio columns, unbounded solution is when my minimum ratio column is all negative. So I want a minimum positive value in this case, which I'm not able to get. So this is called a unbounded solution. So this was an example of unbounded solution. Hope you liked it. Don't forget to like, share and subscribe for more videos on special cases on Simplex. Thanks for watching.